just as we did with compounding, we can discount at more than the annual rate. So if we go back to our example of 7 years, we start at time period 0, 1, 2, 3, 4, 5, 6, 7 years, but we don't want to discount annually, we want to discount more than annually. So we're going to use 6 months as our starting example. We simply cut the time periods into 6-month increments, and we know that n equals 2. In other words, there's 2 time periods for every year. We're still using our 10% annual interest rate, and now we're going to rearrange the math. Remember, the future value equals the present value times 1 plus I divided by n raised to the t times n power. In other words, there's 14 time periods, and the interest rate has to match the time period. So I divided by n in this case is 10% divided by the number of periods is 2. So I is 1.0 or 0.05. 1.05 is the interest rate. The number of time periods in this case is 7 times 2 for 14. Well, this is the future value. All we have to do to the present value is rearrange the formula to move this term on the other side. So the present value equals the future value divided by 1 plus I over n times the number of payments, or exponentially the number of payments. So we just took this term and put it underneath the future value. In this case, if we do the math, we find that this is $100 divided by 1.05 raised to the 14th power. You don't have to do that math. I'm not asking you to do that math. Please don't do that math. I'll show you a much easier way to do it. But the answer here is $50.50 in semi-annual form. If we did it in annual form, we would have 100 divided by 1.10. Remember, the interest rate would be per year, not per 6 months. And then we'd only have 7 time periods instead of 14. That answer is $51.31. So now let's take this back to what we're actually looking for. We know the future value is $100. That's what we're trying to earn. And then we start with something, the present value. We're looking for the present value. In the case of annual discounting, if we deposit $51.31 today and it compounds forward at 10%, every year we end up with $100. If we deposit $50.50 today and it compounds every 6 months at a 10% annual rate, we end up with our $100 in the future. So you can see that the more compounding or the more discounting periods you have, the less money you have to deposit in the present to end up with the same money in the future. Let me say that differently. If you deposit $50 today and you compound it at 6 months, you end up with $100. If you deposit $51.31 today and it compounds annually, you end up with the same $100. So the more time periods there are in discounting, the less money you have to deposit today.